Welcome back to the shrine. Today an equipment that defies reason is in my hand. I saw this on a garage sale and the seller said it's not working. So it's perfect for this channel where I typically repair things. This is a Makita cordless grass shear. I only know that because I looked it up. I thought initially that this is for pruning bushes, but it clearly says that it's a grass shear. The part number is XMU04 and it's an 18-volt unit and 2500, I guess that would be strokes per minute. Quick Google search shown that it's got a 3-stage height adjustment, which I've got no idea how it works. Okay, so there's 15, 20 and 25. I'm guessing that first you engage this and then you snap that in, so it snaps out in the back first. Well, on a good days it snaps out in the back first. Maybe press it here, maybe push it. Okay, there you go. So push it forward, and then you can engage the proper slot here, and that will adjust how far this deflector is from the blade, and that will adjust the cutting height. I can imagine that somebody sends these to the GIs who serve in the Gulf and they are missing the grass, so in front of the tent they're gonna grow grass, and this is perfect for that. What the heck is this? What is this? Lock, unlock. Okay, so you press here and then what? Okay, so that rotates. I see. So that's how you replace the blade. Ah, there you go. Huh. Interesting. So that is the blade, and you can see that it's a pretty complex piece of machinery. So we got one blade here, and then there's a lower one, and it looks like there's a guide. This black one is a guide, and so it's doing this shearing motion. So these two blades move relative to each other based on where this cam is in space. So the cam is basically just spinning, and that is moving the blades back and forth. Well, since I'm here and I got a brand new battery, I might as well test it. The battery is fully charged despite the red LEDs. Every manufacturer has green LEDs, and then it turns to red when it's dead, or it only shows like 1 bar instead of the 4. Well, Makita decided to go with a red color. There's probably a reason for that. Maybe the red is the cheapest one. There goes the cam, contact, and looks like this lock is not locking and the switch is not working. I have a feeling that somebody has been inside before. So this is just a cam that attaches to the motor, and there are 2 pins here, and those pins transmit the rotation, the rotational motion. Let's go inside and see what might be wrong with this thing. Phillips screws everywhere, so there's nothing tamper resistant on this one. I guess Makita doesn't care if you go inside and tear it up, since you already paid for it. So 6 bolts Let's see what's inside, how many parts this will fall into. Huh. Not much, I gotta tell you. I think many times about the guy who has to program up the CNC to create the mold for this one. As you can see, it's a two-piece mold, so we got some kind of TPE, and then this is PA6, so this is just polyamide 30% glass filled, and then they shoot it with this rubberized, texturized, melt in your hand, black plasticky thing, just for your finger pleasure. So let's have a look here. I'm not sure what this switch is doing, but it's not really locking anything, so I think that would be designed to lock this switch. So you can see that power comes in on this side, and then we got 3 wires. So this pink wire and the black wire, those are probably carrying the voltage to the brain box here, and then this yellow wire, it's just telling the brain box if I installed a Makita battery pack, so there's some kind of logic in it. So it this battery pack tells the unit that it's legit. So it's a proper 18 volt. There's probably some doublery going on. So you can see that the switch is switching the voltage here. So the pink wire goes to the switch, and then another white wire carries the voltage to the brain box, and then the brain box is controlling the motor. And this switch doesn't have a manufacturer on it. It's 16 amps, 1/2 horsepower, 250 volts AC, or 0.6 amps at 125 volt DC. So it's a pretty beefy switch. It's got a good clicking action. So first thing we need to do is we need to figure out if I connect the battery here, if we got proper voltage. So let's do some measurement. Hook up the battery. So right there we got 19.44 volts, so that's good. So that voltage comes here, and then no voltage once I actuate. Uh-oh. What did just happen? Oh, look at that. It's working. It's working. Huh. Well, that's a strange thing, I gotta tell you. Because it wasn't working before. So look at this. So it's working, but it's kind of surging. I don't know if one of these wires got pinched, but as you can see, I didn't do anything. I just popped the cover open, and before that it didn't work, and now it's working. Well, this is what we typically call no trouble found. The unit looks to be brand new. I don't think this was used much, and there is really no serviceable components here. Once this thing goes, that's pretty much end of story, because you can see this electronics box here. It's placed in a plastic container, and then it's potted. It's completely potted. Now good luck removing the electronics from here or servicing it. This is one of those stellar examples of that throwaway society. Let's see how much current it draws. So this meter has an inrush. About 5.1 amps inrush current. And during normal operation it shows below 1 amp, so 0.3 to 0.8 it changes, because again the motor is surging, and right now we're just running free speed. As far as bearings go, there's not much. So here is this one. So we got one shim on one side, and then there's another shim on the other side, and this is a ground pin, and it's directly mated to the gear, and the gear is molded, so it should have a tapered hole, and accordingly in one end, you can see on this end the pin has a play, and then on this end the pin doesn't have a play. So probably this gear is cored from this side. So here's a large gear, it has a shim on this side, and then look at the pin here. So the pin has a cut, and that cut interfaces with the plastic here so that the pin would not walk out. This pin for the small gear is captured on both sides. Here's the motor, ON146Z27 CCW15, 37.3 millimeters in size, and it's got this big beefy gear press fit on it. It only has 8 tooth, and because of that you can see this is not a beautiful spur gear, but it's rather what we call a stop gear. The motor has a bolt on one side installed, and then these beautiful people, they marked this side as red, and then this side is not marked. So there's no marking about positive or negative side, but right here this wire is red and then this is black. So I'm assuming this is negative and that is positive. The motor turns freely, you know, it will align the rotor, the armature is gonna align itself to the magnets. I've taken these apart in the past. I don't think I can gain much information with that. I don't see a reason to take it apart. So these are the brushes inside. So I can go and test the brush tension, and I can tell you there's a lot of brush tension there. Same on this brush. So as far as the motor goes, it checks out. Whatever you do, don't try this at home. The motor seems to be okay. It's just directly connected to the Makita battery. It's running no problem. It's not surging. So I suspect that this controller here is not good. That's why it's surging. Well, here's the electronics, or at least what left of it. And then this is the plastic that was encasing it. I chipped it away piece by piece, and in the meantime it occurred some damage, but at least we can see clearly now what's on the PCB. So we basically have some kind of op amp here. This is the micro, and then this is just a rectifier. So this is the rectifier that is connected in reverse. Some people call it a freewheeling diode, and what it does when you disconnect the power from the motor, it's gonna attenuate that voltage spike. This was the LED light that lights up when you turn it on, or Probably this can flash some error messages. As you can see, it's properly broken off. So there's not much left to do with this guy. I looked it up online. It costs about 50 bucks new, and I'm not sure I'm gonna get the same part number and the same cable length and all that jazz. So what I decided to do is just go with the off-shelf motor cutter, and long and behold, eBay delivered a little bit late, but nonetheless it's right here in front of me. So there's not much on this guy. You basically got 2 inputs, 2 outputs. There are some caps here to smooth out the current. There's some switching MOSFETs. There's some burrs from China with love, and this looks to be a half bridge DM do-it-yourself more do-it-yourself-more.cc. Some Chinese characters, power negative, power positive, motor positive, motor negative. That's pretty much it. So I'm gonna go and wire this up and then hook it up and see if it runs. Snippy. So that's all we need. This yellow is just the sensing terminal on the battery. It tells something to the brain box, so I will just unplug it just like that. So make sure you don't mix up the wires. Again, this is negative here. You can see power negative, and then here clearly it says negative, and then for the positive right there, the red wire for the positive, it says positive. So it goes into the switch breaks it unless you press the button, and then it comes in here. So that's the power positive, and then obviously the motor output is just motor positive, motor negative. So I'm gonna hook it up like so. Here's the battery and contact. It works like a hot damn. Now this one has a potentiometer on it, and it's almost at maximum. So this guy is giving us 18 volts. Obviously there's a little bit more than 18 volts in it. So 18.7 volts goes to the motor. Now I'm looking at the motor, and it doesn't really have any spec on it. It says made in China, QN 14627 whatever, CCW 15, but it doesn't have voltage. It doesn't show what voltage the motor is rated at. So I need to look this up, make sure that I'm not feeding 18 volts to a motor that's designed for 12 volt. I can also alternatively turn this on and come in and then just bring down the dial. You can hear on the pitch that it's controlling the voltage. So now we have 13 volts. So this is all doable. It works. Continuous duty free speed test. Run it for I don't know, 20 minutes. See if something will let the smoke out. Picture in picture. Looks like the motor is running at 25 degrees Celsius. The electronics is a little lighter, so it runs 28 degrees, and the battery is cool. It's 23 degrees. You can see the motor is about 28 degrees. Nothing is overheating. It's been running for, I'd say, 10 minutes. You see, it's less than lukewarm. It's drawing about 0.4 amps from the battery. I think we're gonna be friends. Look at that, that's like the lowest speed. You can count the pulse width modulation pulses. Look at that. It goes to full stop. What I'm doing here is I'm turning the pot. Just look at that. Just have a look. See how nicely it fits? It's like it's designed to be right in that spot. The heatsink is gonna have enough surface area to cool it, and then I hit the potentiometer in this cavity here. I cut the plastic a little bit. Look at this. It fits like a glove. Huh? Seamless. I think that's what they call seamless. Back in one piece. It's a lean, mean cutting machine. Look at that. You don't want to be on the business end of that thing. It's well balanced. It's not really shaking and rattling my hand. What's missing this tray, which, as I shown earlier, goes like so. There you go. And this part here, I'm not sure what I'm gonna do with it. Probably just pitch it. Still don't know what was the problem, but it was surging. If you want to take the surging out of the shears, just get one of those motor controllers and it'll be fine. What else you can use this for? Let's see if it can cut this. This is dangerous. Not supposed to leave it with your ex-wife, that's sure. Thanks for joining in today. Hope you guys got a kick out of this repair. Until next time, see you. Bye. It's great for trimming those hard to reach areas.